Hello again. We are continuing our discussion of parametric equations, and today we're going to talk about how to calculate speed and total distance using parametric equations. So what's the difference between velocity and speed? Well, velocity we expressed in the last video as a vector where the x-coordinate of the velocity was just the derivative of the position for x, and the second coordinate was the derivative of the y position. I can also write that as dx dt and dy dt. So speed, remember, is independent of direction. We don't really care what the direction is when we're talking about speed, so I say that it is the magnitude of velocity, just like it was when a particle was traveling back and forth on the same line. So the horizontal velocity, remember, is dx dt according to that vector, and the vertical velocity is going to be dy dt. So if I want the overall speed of the particle by using those two numbers, then I'm going to be looking at the hypotenuse that I create with that triangle. And so Pythagorean theorem gives us the speed as the square root of dx dt squared plus dy dt squared, or x prime of t squared plus y prime of t squared. So that's how I'm going to figure out speed. Now for total distance, it does not take direction into account. So whichever direction you're traveling, we really don't care. We just care about the total distance that you're traveling. So since total distance doesn't worry about direction and speed doesn't worry about direction, I can actually consider total distance to be the sum of all of the speeds that I've been traveling through the course of the time that I was traveling. So I'm going to add all of those speeds together, and I'm going to multiply the speed by some change in time, and I'm going to look at the limit as the change in time approaches zero, much like I did with derivatives and integrals and stuff like that. And as you know, when I take a sum of things and I let the space between those things go to zero, there ends up being an infinite number of them. So I use an integral instead of a sum, and that's the integral that I get. The total distance is going to be the integral of, from A to B of all of my speeds. Okay, and again, I can rewrite speed as x prime plus y prime, both of those squared under a square root. Okay, so here's an example. At time t, the position of a particle moving along the xy plane is given by the parametric functions this and this, where x prime is 2t plus cosine of 5t squared, and the graph of y is shown here. So I don't really have a function for this, but I can read what the y coordinates are for every point. So I need to find the speed of the particle at t equals 4. And I need to find the total distance traveled by the particle from time 0 to time 2. So let's look at the first part. I rewrote the derivative of x at the top of the screen, and I still have the graph of y on the right-hand side. So let's find the speed of the particle. When I plug in t equals 4 into x prime, I get 2 times 4 plus the cosine of 5 times 4 squared. That is 8 plus the cosine of 80. That's going to be about 7.890. Now to figure out y prime of t, I simply need to look at the graph when t equals 4. So when t equals 4, it's traveling downward on that sloped line segment there. That segment has a slope of -0.5. So at t equals 4, y prime is going to equal -0.5 or -0.5. So now I have everything I need to figure out my speed. My speed is going to be that formula there, plugging in the 7.890 and the -0.5 that I've already figured out. And that gets me 7.905. So that's the speed of the particle at time 4. All right, now I need to find the total distance traveled by the particle from t equals 0 to t equals 2. So there's my distance formula right there. But because y is piecewise from t equals 0 to t equals 2, I need two integrals. The first one from 0 to 1 and the second one from 1 to 2, because the slope is different for each of those pieces. So there's my distance formula. The first integral goes from 0 to 1 and the second one goes from 1 to 2. I'm just going to plug in my derivative for x prime of t, and I'm going to plug in the two values from the graph into y prime of t. So now I go to my calculator and I calculate each of those separately. You'll see that I typed in the first expression in here and the second expression in here. And when I did that, I got 2.345 as an answer to the first part and 3.141 as an answer to the second part. So if I add those together, I get a total distance of 5.487. And that's how you do speed and total distance with parametric equations. If you have any questions, please let me know, and I will see you tomorrow.